What's up, guys? In this video we're going to learn about what a logarithm is, as well as evaluate some simple logarithmic expressions. Alright, here it is. Okay, so to help illustrate what a logarithm is, I'm going to start with an equation that we should all be pretty comfortable with understanding here. And so if I have some base, we'll call it 10, and I raise that to an exponent of x, and that equals 100, well, we can use reasoning to see that the exponent, in this case, x, would have to be 2. Alright, because 10 raised to the second would give us 100. So all logarithms are just a different notation to express this exact same situation. So for example, we'll start with a pretty simple logarithmic expression. Okay, and how we read this is log base 10 of 100. Okay, and we're going to evaluate this expression. So this number here, this little subscript here, is called the base. And the key to understanding this concept is that the reason this number here is called the base is because it represents this base, this number in this equation. This represents this. Okay, they're both called base because of the fact that they're the same thing. All right, and so if I have this expression that says log base 10 of 100, and I want to know what that equals, well, I'm asking what exponent would I raise a base of 10 to? In other words, what exponent, x, would I raise a base of 10 to get 100? And as we know, the answer to that is 2. So as you can see, this equation here and this equation represents the same situation. It's just, you just have to interpret it a little bit differently. All right, but the key is, again, to put together that this is the base. So whenever you're trying to think about, which number is which and all, the subscript represents this number here. All right. So we'll do a few of these, several of these actually. So the next one we'll do is if you have something like this, all right? And this one says log base 2 of 32, and I want to know what that equals. Well, again, let's sort of create the situation here. So again, this number here is called the base, so that's going to represent this number here. So I have 2 as my base, raised to some exponent that I don't know, and that would give me 32. Okay, so what exponent would you raise the number 2 to get 32? And the answer to that would be 5, because 2 to the 5th power gives me 32. All right, we'll do one more of these and we'll get into some slightly trickier ones. All right, log base 9 of 1. Again, this is the base. So if I want to know what log base 9 of 1 means, I'm asking what exponent would you raise 9 to in order to get 1? And the exponent in this case would be 0, because 9 raised to the 0 power is how we would get 1. Okay, so logarithms are just another word for exponents, basically. When you're evaluating a logarithm, you're figuring out what the exponent is. All of these values here are the exponents. Okay. So here sometimes we can get some fractions. So we want to know what log base 3 of 1/3 is here. And so let's sort of create the situation again. So a base of 3 would mean a base of 3, and I want to know what the log is. So I want to know what exponent I would raise 3 to in order to get 1/3. And the answer to that would be -1. All right, so logs can be negative because exponents could be negative, because logs represent exponents. So if an exponent can be negative, then a logarithm could be negative, right? Because 3 raised to the negative first power would be 1/3. Okay. Log base 2 of 1/8. So the base is 2 in this case. And what exponent would you raise 2 to get 1/8? And that's going to end up being -3, because 2 to the -3rd power is 1/8. All right, and then we'll cover one more situation here, or type of situation, I guess. Log base 9 of 3. So the base is 9. Now I want to know what exponent you would raise 9 to in order to get 3. So here we're raising 9 to an exponent and we're getting a smaller number. So the key here is to see that 3 is the square root of 9. And so the exponent you would have to raise 9 to get 3 would be 1/2. Because raising 9 to the 1/2 is the same as taking the square root of 9. All right, so again, just like exponents can be negative, so logs can be negative, exponents can be fractions, and so logarithms can also be fractions. And we'll do one more. Okay, log base 125 of 5. So base is 125. And we want to know what the exponent would be to make this a true equation. And then the key to this is to realize that 5 is the cube root of 125. So the exponent that we would raise 125 to get 5 would be 1/3. Because raising this 125 to an exponent of 1/3 is the same as taking the cube root of 125. All right, so in the next video, we'll do some more difficult examples of evaluating logs, and then we'll even get into some logarithmic equations as well. All right, and with that said, it's been demonstrated.